Alrighty, halfway through the week. Thank you guys for showing up today. Appreciate it. You guys are probably my best attended class, so keep up the good work. Today we're going to start off with the warm up over heat and energy transfer. All right, so question one is when a steel block is 100 degrees Celsius placed on a copper block 20 degrees Celsius, thermal energy of the copper begins to increase. Which of the following is the source of the energy? All right, so um, the work done by the molecules in the copper, work done by the interaction of the two metals, heat flowing by means of conduction, heat flowing by radiation. So it says right here, placed on top is the key. All right. So um, there is work being done by these two, A and B. Okay, but like it's not the best answer. So the work done by the molecules within the copper is not just true because it's also the other block that was there too. Um, so what happens is uh, heat flowing by means of conduction. Conduction is the transfer of heat or energy by touching, the physical touching of the particles. Radiation is the opposite of conduction, basically. It's done by waves through without a medium or anything to transfer it. So it's not D, it is C. C is the correct answer. Right? All right. A container of cold water is dumped into a larger container of hot water. That should say mixed. It's mixed and then left alone for a long period of time. The water temperature is found too. Okay, so the water is going to transfer energy until it reaches an equilibrium, which is where the temperature is the same throughout. Okay, so you've probably all experienced this, whether you've like got in a bathtub or a swimming pool and someone's added warm or cold water to it. Or even if you think about an ice cold drink, if you get ice in your drink and you leave it out, the ice will melt and the temperature of the drink will become the temperature of the room that it's in. So you leave ice outside in January, the drink will probably still be pretty cold by the time you come pick it up a couple hours later. Is as in if you left it out now in June, it'd probably be pretty warm. Okay, so the temperature will be uniform, which means the same throughout the container. Next up, which is the best example of heat being transferred mainly by radiation? Now, radiation, remember, is the transfer of heat by waves, right, without the use of molecules. So when we're rising from the ceiling to the top in a room to the top floor, all right, that is warm air rising. That is, excuse me, that is a fluid. So if fluid would not be radiation, that'd be conduction or kind of convection. All right, the end of a metal spoon getting warm and placed in a hot cup of tea. That's transferred by the water touching the hot spoon. So that is a conduction example. A bench getting warm by placed near a fire. All right, there's our answer. All right, so the bench is placed near a fire. It is not touching the fire. So the radiation coming off the fire is heating the bench. All right, fire and heat does give off radiation. It's called infrared radiation. I'm not sure if you guys remember that. Maybe it rings a bell. And that ends up heating up the bench. Question 4. Which of the following objects is the best conductor? So we talked about how solids are the best conductor. So you can ignore air right away. And then you got to think about, all right, which type of solid is the best conductor? So in the solids where the molecules or atoms are closest together, can transfer heat quicker back and forth. So plastic and wood are both bad conductors. We use them to pick up hot things, so it cannot be B or C. So the correct answer is A. A. We use wood in like a some pots and pans have wooden handles, or some pot holders are made of plastic, because they don't transfer heat well. And when you pick up something hot, you don't want the heat to be transferred to your hand, because that's how you get burned. So you want to use something that's bad at transferring heat when you pick things up, hot things up anyways. All right, heat always moves from a blank object to the blank object. All right, so heat always moves from the hotter object to the colder object. So it's the object with the higher temperature to the one of the lower temperature. So heat always goes from the high temperature to the low temperature. If you think about anything you could do right now, if you go outside and you put your hand on the pavement after the sun's been on it for a while, your hand is not as hot as the pavement. So it's going to transfer energy to your hand. The object, when you feel heat coming in, that feels hot. Your body reads that as hot. When you are transferring heat somewhere else, your body feels that as cold. So if you're in a cold room, your body is transferring heat from you to the air, which is why you feel cold. And when you put a blanket on, it traps the heat inside so that you're not transferring the heat and you stay warmer. All right, Kadeem, you asked about question 3, the bench getting placed near warm fire. It is transferring heat without touching it and without the circulation of a fluid. So water or air is not circulating. All right, the last one you can ignore because it says hot water. You know right away, water is not transferred by radiation. All right. Any questions on the warm-up? Okay. All right, so here's what we're doing today. Today's gonna be a makeup day. So I noticed yesterday when I was grading assignments that we are still missing a lot of work. So make sure you go through and you make sure you're getting caught up and you've turned in all your assignments. Think about every warm up, every notes, every we did a PHET doesn't have a lot turned in. The practice calculations for kinetic potential energy and work and power. I'm missing a lot of those. So those two are really important to get done. These practice calculations. All right. The notes should all be pretty simple. The Nearpod link is posted in the assignment for you to do. So all you gotta do is click on the link, and then it'll take you to a self-paced one, which you can do on your own and turn in the notes. We're missing a lot of work. There are a few guys that are on top of it that have turned in like 80% or more of the assignments. Thank you very much. I really appreciate that. That's going to make your life a lot easier. Also, do not forget about these weekly assessments. They are important because those are like the end of the week tests. All right. So the weekly assessments are in each folder. They are labeled weekly assessment. Tomorrow will be a review day. So instead of doing a weekly assessment just for this week, we're going to do one for the entire month we've gone over. So that's atoms, work and energy, the periodic table, and heat. Those are like the things we've covered this month. So that's what our test will be over on Friday. It is for a grade. It's compared to the one, I'm going to compare it to the one you did before to see how much you've grown. And you should have grown a bit because we've covered this stuff again. So also, I'll make sure you guys are prepared for that tomorrow. Tomorrow we're going to do a review. We'll play, probably do a game or something, and I'll walk you through some of the key concepts that we need to do. So on Friday, what we're going to do is we're going to be taking this survey for a warm up, which is kind of like the end of the summer survey. It's not a survey that I made. It's going to be one that the district gave to me to give to you. They want to know what you think about online learning in summer school business. So mainly what they're looking for is how you feel about this online learning and how that's going to apply to the upcoming school year. So that's our game plan for today. Please, please, please use this time wisely. Get your work done. Stay online. Ask me questions. All right. Make sure you get help if you need it. That's what I'm here for. So I will stay online until see 10 o'clock. All right, because class is over at 9:50, but I'll stay on until 10 today. All right. So make sure you are getting this stuff done. All right. Anyone have any questions before you guys get started? If assignments aren't working or you click on a link and it's not coming up, or if there's any technical issues, please make sure you let me know too so I can fix them. All right, go ahead and get started and let me know if I can help.
First,